All right, in this one we'll look at a fourth trend in this chapter. This one's called electron affinity. Electron affinity is the opposite of ionization energy. Remember, ionization energy was the energy that it took to remove an electron from a gaseous atom. Ionization energy is the energy needed to remove an electron from a gaseous atom. But electron affinity is the energy change when an electron is added to a gaseous atom. So ionization is the removal. Affinity is the addition of an electron to a gaseous atom. Notice both are gaseous atoms. So the equation would look backwards of ionization energy. So the ionization energy of fluorine would be the loss of an electron, but the electron affinity of fluorine would be fluorine gaining an electron. And so we'd end up with fluorine plus an electron giving us fluorine minus 1. And there would be an enthalpy associated with this. This energy right here, negative 328, would tell us that it's an exothermic process. Energy would be given off when that fluorine gained an electron. Not all electron affinities are exothermic, whereas in ionization energy, it always takes energy to put into an atom to remove an electron, so they're always positive. Many electron affinities are negative, but not all of them. A very general trend that doesn't hold true nearly very well at all is on your digital book, and I'm giving you kind of the look at it right here on page 311 digital book. And they only look at what are called the representative elements, and that's groups 1 and 2 right here, and then groups 3, 4, 5, 6, 7, 8, and they kind of omit these guys right here. And you can see that in general it becomes more exothermic as you go to the right. You'll see a lot of anomalies in the middle, but you can see that generally the most the exothermic ones are over here in the halogens. And you'll see that the noble gases, of course, they don't want to have to gain an electron or lose an electron either. And so that's why there's our greater than 0 right here. So electron affinity has a lot of anomalies to it, but the general rule is that as things gain electrons to become more stable, like fluorine would then look like neon, they'll be exothermic. If they gain electrons and then they would not be stable, like you see in beryllium and magnesium, they'd have to gain an electron and then they'd end up having the 2p or the 3p orbital filled, then it would generally be endothermic, and you can see that happening here with all the noble gases as well. So just know the difference between the two. Ionization energy is the removal. Electron affinity is the addition of electrons.